because we're going to try to do the same stuff. This was one of the few word problems that we have not done that was in the old book. And when you get into the new book stuff, there really aren't any, to be honest with you. There are very, very few word problems whatsoever, which is kind of annoying. Hi!
How do you make a fractal formula?
Alpha y equals. Oh, I should tell them. What was it? Alpha zoom for matrices?
Yeah.
Oh, or for whatever. Hey, bozos, you might also need to know how to do alpha zoom. Okay. Okay, good luck.
Why did she come to the door?
They're not sitting next to each other, so it's okay. Anyway, so one of the styles that I want to remind you guys of what things mean. What do the parts mean when you're looking at them in terms of what we call an initial velocity problem? You guys had initial velocity problems on the test. The only one that was different is that your copy, I think you guys had a value that started at the origin. You did not have one that started at a specific height. We did once in class, the Jackie Joyner-Kersey shot put one. It started at what, 5.5 feet up off the ground, because that's where the shot put rested on her shoulder. That was the initial height, and you were trying to figure out from where did it go. So when you get these initial velocity problems, some specific height is going to be equal to, in relation to its time in the air. So your height becomes your y-axis, time becomes your x-axis. So you have some height versus some time. Now, when you read a problem like this, it's telling you that the juggler is throwing a ball into the air, releasing it 5 feet above the ground with an initial velocity of 15 feet per second. I have given you guys that formula in the past. I haven't had you guys write it out. So you guys would have been given some height equals negative 16t squared plus 15t plus 5. Analytically, what I want you guys to interpret what that value of 5 stands for is that when time is 0, what's your height? 5. It's the initial height. It's the y-intercept. Your value of c in any quadratic, when you have a quadratic in standard form, you want ax squared bx plus c, that value of c will always, always, always be your y-intercept. So this problem we know starts at 5. With the gravity at negative 16, does this mean is it going to be up like a cup parabola or down like a frown parabola? Down like a frown, yeah, down like a frown. I almost said prawn, that's a shrimp. And then I thought of under the sea. Now, if you're throwing something up in the air with some initial velocity, this value of b gives it direction. If it's straight up, there would be no b value. Since there's a b value, it has an arc. That's what creates the parabola part. Otherwise, this game goes straight out. Now, excuse me. The problem asks you, she catches the ball with the other hand, so it starts at 5, and she catches it at 4. Starts at 5. It doesn't stick to landing. The Russians give her a 2.0. So, thank you. I don't know why not. So we're looking at when does it get to here at 4. The time that you're trying to account for is this value here. Yeah, not drawing the scale. Thank you. And that should just be like a disclaimer on every picture I draw. So just remember, everything you see, take with a grain of salt that it's not drawn to scale. Not drawn to scale? Is it going to be a skewed shirt too, so one sleeve shorter than the other? Yeah. So we had a question earlier today that was saying that since the velocity is 15 feet per second, if it's moving, technically you're looking for a 1 foot drop. That would be 1/15 of a second. See where I'm going with that? But there's an arc to it, which means more time will elapse. It's not a linear stop. Well, it takes time to go up and come back down because of gravity. Gravity, I know, I'd say it's something, but that's wrong. Okay? So gravity is telling it it's going to go up and come back down, where we want to figure out where does this height then equal 4? Because that's what it was asking us in the question. Now, a couple ways of going about doing this. Whenever I have an equation, I'm trying to solve for something to equal 4, and it looks like it might be kind of a nasty equation, or basically any of these, I'm going to always set this equal to 0. Because if I set this equal to 0, I get that. Which means I could figure out my zeros for that problem. I can do this a couple of different ways. I could try to factor that, but I don't want to factor something that has a leading coefficient that's negative. I will usually screw that up. So I'm going to use, I don't want to complete the square because that'd be a nasty fraction. I can use the quadratic formula real quick, and it actually works rather fast. Rather quickly, I should say.
Why is it +1 instead of +5?
I set it equal to 0 so that way I can find my zeros. Because if I set this equal to 0, this graph changes.
Never mind, I see what you're saying.
This, what's that?
Where it is at 4.
I am. By figuring out where this is going to equal 4, if I move it around, I set it equal 0, then I can use quadratic formula. I can use my table. I can do all that other stuff. Because those are finding zeros. Yeah, you can do that too. But sometimes, yeah, sometimes it won't work cleanly though. So this case, it does. I know this one does work cleanly, but I'm going to show you the worst case scenario if you did have to use quadratic formula. Sometimes you do. And when you use the quadratic formula, you have x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So I just plug and chug, okay? Negative 15 plus or minus the square root. I think this is what ends up to be 289 all over negative 32. Square root of 289 is 17. And this is why the table function works out nicely, because it gives you clean numbers. Sometimes it doesn't. Okay. So in this case here, what's negative 15 plus 17? 2. 2 divided by negative 32 is negative 1/16. Am I looking at negative time? I don't have a DeLorean, it's not going to work. So now I do the other version. What's negative 15 minus 17? Thank you. And what's negative 32 divided by negative 32? 1. How much time allotted? 1. 1 second. You can, but what happens is, and that's what Jan was saying, is that the table function is a great thing to find. It works out just as well. But sometimes it might not show up on the table. It could be between values, and you won't know that. Obviously, in the table, if it skips over from positive to negative, you know it could happen between 2 and 3. And then you can use quadratic formula, or you can use calculate 0. Any one of those ideas. Okay?
I just go usually like in the y equals, I'll usually just put like the equation and then I'll put like 4 for the y equals below it.
Yeah.
4 and then I go to like the actual graph and just find their intersection?
No, that's fine. That's one way of doing it. Absolutely. Because what you're doing there is you're just finding the intersection of these 2 points. You're just figuring out where they run into each other. I never even thought of it doing it that way. We did that with one problem, didn't we?
Yeah, we did that with the fire one.
Yeah. Look, you guys remembered something. Yay, you're fine. Like a double fight. Oh yeah, what you did too? All 3 of you here, karate chop.
Moving on.
I got nothing. So yeah, Jade, in your case there, when you're saying look at the table, that's fine. But sometimes the table will be between values. Okay? Sometimes you're going to get a y value that doesn't show up as a 0. Okay? If that's the case, you'll see in your table that your y values are decreasing. All of a sudden, they'll jump from positive to a negative. That just means it occurred between those 2 values, which means you'd have to go through and do that, your second calculate, and you're looking for a 0, okay? And you're doing that. And it works the same way.
This is why I feel like I did it wrong.
On the calculator? Okay. Let's go back to our y equals. Let's put this, hey, convenient. I'm going to put this graph in here after I've set it equal to 0. Okay? So I have negative 16x squared plus 15x plus 1. And when I have that, now all I'm going to do is go to my graph right away, just to look at it. You might have to adjust your window. My window is set as a regular basic 10 by 10. If you need to adjust, you can adjust. It just takes a little time to get used to that. Now, I'm trying to figure out where it crosses the x-axis. So I'm looking to find its 0. Second, calculate. Option 2 is 0. Okay? Now, with your cursor, when you're moving your cursor on the curve, you're moving left and right. Your cursor is moving left and right, and it'll follow the curve accordingly to the y values. So as I go through this, if I'm moving left and right, I want it to be to the left of where it crosses the x-axis. So in this case, you'll notice it would have to be a positive y value. And then to the right of it, you'll see that it is a negative y value. Those are the 2 left and right bounds that I will choose to do the calculations. So it's asking me left bound. Well, I want my left bound to be about there. Hit enter. Right bound. Hit that one and hit enter. Guess. Well, it doesn't look like it's 65 degrees out like it was earlier. It looks like it's like 50. It looks cold and crummy. There's my 0 at 1. Error. What did you see? You know what?
I did it on the test too. My matrix wasn't working on the test.
Detecting a sign change to give an estimated result for allowed number of iterations. No sign change. Oh, I know. I bet you I know what it was. I wonder if you're. When you did this, when you hit your calculate 0, you want to be here, here. You might have been You might have been picking your left bound on this side of the graph to find that 0 to the left, and then the right bound on that one. You have to you want to try and 0 to 0. You want to be as close to approximation. That's probably all it is. Yes, ma'am.
Another rubber.
Your window that's all. So you're in the maximum. That's all. Big hit. So your window here, so now it's just like mine. Your window, my scale was at 10 marks. At 0, so you put that in 1. So, hey guys, it's another good thing that happened. I haven't seen this problem yet. Sometimes you might not be able to figure out what in the world happened to your graph. Why did something show up so weirdly looking to everything else? I don't know what to do to make it work. This is when we have to remember the October button. How to restart. How to set it over again, okay? The Control Alt Delete for these calculators. Second plus sign. You're gonna do a second plus 712. That restores everything. And then second plus 722 resets defaults. The important thing for that, what's that?
By the plus, are we saying like the plus?
The plus sign, yes. Second plus sign 712, second plus 722. What this second value is, the resetting of the defaults. By resetting the defaults, thank you, it'll fix your graphs. It'll send everything back to a 10 by 10. It'll put back in all the tick marks. It'll change everything back to that so it makes some sense.
So I just, like,
Yeah.
my battery went up.
I don't know. Who knows? Yes, sir.
Did that clock stop working today?
Yes. I think it started sometime over the weekend.
Still working yesterday.
You know, we're in one, in case you didn't notice, we're in one giant DeLorean right now.
Yeah.
I'm sorry. What do you got, Hannah? Save me, please. For this problem, yes. For this problem, it does work out to because the zeros are usually fine. Okay? Sometimes they're not as clean. Okay? Now, another thing that people are having problems with is we go back.
It's only 2 minutes. It's 2 minutes.
If I go back and look at cost sales style problem, what I want to do is we had a really good discussion about what in the world does it mean again. And I think second hour came away going, oh, I'm an idiot. No offense to second hour, but wow. But what I want to do is just kind of re-go over what in the world is really occurring when you're dealing with cost sales values. Yes, sir.
Wait, never mind.
Yes, we did do this problem.
I just met him too early.
That's okay. So we've done this problem. It's the shoe problem. It was the first one that we did that looked like this. I think it's a very easy style problem because every other problem that looks like this means basically the same thing. The only thing that changes are some number values, some prices, the sales figures, things like that. The way that the setup is identical for each and every one of these. So in the shoe sale one that we talked about before, it said for if you sold shoes for $60, you would expect to sell 200 pairs of shoes. So this is the type that you would have your cost and your sales. Okay? At a cost of $60, you would sell how many shoes? Well, technically it's 400 shoes, but you know. 200 pairs of shoes.
That wasn't price.
She sells
Single shoe.
Sorry, that was. Is it June yet?
Yes. I'm leaving tomorrow.
Now, for every single $1 increase in the price, for every $1 increase in the price, you expect to sell 2 pairs of shoes fewer. So that means if I increase my price by $1, what's my new price? 61. If I increase my price by $2, what's my price?
60.
If I increase my price by $5, what would my price be? So I'm increasing it $1 by 5 times would mean I'd have a price of $65. Now, by logic, that means that if I increase it 5 times here, if I increase 5 here, that means this would have to also be 5. This value of x is just the multiplier. It's the multiplier. How many times did you increase the price? I increased the price once, twice, thrice, bless you, 4 times, 5 times, and so on, okay? I just made that up. It's actually a Simpsons reference, but whatever. So that's what that means. That's what those x values represent. They represent multipliers. They don't represent price, and they don't represent sales figures. They represent how many times something has been increased, and then how many times your sales figure has changed. This style problem was the one that I showed you guys that was always the easiest to set up using intercepts. This is intercept form. What we can do here is find zeros right away. Because by finding zeros, I can get a midpoint, which tells me the value of x, the multiplier, that will give me a maximum sales figure. That multiplier is what we're looking for. So if I set both of these terms equal to 0, so we have 60 plus 1x is 0, and 200 minus 2x is 0. I get zeros on both sides at negative 60, and another one here at 100. Everybody okay with that? What's that? I set it equal to 0 and solve for x. That's all. Okay? Now, if you FOILed this whole thing out, would this be an positive x squared or a negative x squared? It'd be negative. This is going to be a down like a frown problem. So somewhere between negative 60 and 100 lies my midpoint. What's negative 60 plus 100? 40. And what's half of 40? 20. So at an x value of 20, if I increased my price 20 times, my new cost would be how much? 80. That's what that means. This is the how many times have you increased your price? 20 times. If I increased my price 20 times, my new selling price would be $80. What's that?
How is there only 40 between negative 60 and Isn't this like 40? I'm confused.
But aren't they?
Okay.
You add the two. All you're doing is find an average. It's a midpoint.
Okay,
That's an average.
I was gonna say, I'm like, how is it like only 40 between negative 60 and negative?
It's not. Right, but there's 100. But now, if you go through it, well, there's actually 160 to it too.
Oh yeah.
Isn't this 80 apart? And this is 80 apart? So
Okay, I get it.
it's the halfway point. Okay. So this 20 is how many times has price been increased? Okay. So if I increase my cost to $80, I should expect to sell 200 minus 40. I expect to sell 160 pairs of shoes. That's how many pairs of shoes I would sell because that's the multiplier. I multiply those two values together then to give me my sales figure. Now, one of the things that I want you to recognize though is that if I increase my sales, or increase my cost 100 times, my x value is 100, what would my new sales price be? If I increase my price 100 times, what's my new sales price? How much? 160. It means so what this is telling me, if I increase this 100 times, my new sales price would be $160. At $160, would I sell anything?
Nope.
No. If I decreased my price 60 times, what would my price be? 0. Would I make any money? No. I don't make any money at my zeros. because that's where things equal 0. I make money between the zeros. When I'm between the zeros, I have profit. It's above it. That's how money works. You want to make money. I don't want to mark it down to 0 and say, hey, shoes for everybody. I could, that's a nice thing to do, but I won't make any money. My children won't eat. How would you like that? But they're still not going to eat. Okay?
They can donate to you.
Right. Now, if I go through the same idea, this specific style shoe, nobody's going to pay $160 for it. That's too much. That's what this is saying. This price is too much for what the market would bear. That's what the economics would say. Okay. All right. That's what that means when you're on the zeros. You make no money. Does that help for this style? Because I know there's been a lot of questions about what does the X value mean. The X value here is just representing some sort of multiplier within the prices. If I multiply it 20 times, I get my highest cost. If I'm trying to find a specific sales figure, if I'm trying to figure out how many times would I had to have what price would I sell 100 pairs of shoes? Well, if I need to sell 100 pairs of shoes, my X value had to have been, what would that be, 50? So I'd have to sell, my X value, my cost would be at $110. That's what it's asking you. Things like that. How do you manipulate the value of X to determine cost and sales? Those X values in your table are just multipliers. It's the same thing if I would have thrown this in a calculator. Y equals, clear this out, parentheses, was it 60 plus X?
I think this is what I did when I got the boat thing.
It'll work the same way, but here's the problem. With this one, you really have to move your graphs to make it fit. That's why when I do cost sales ones, I do zeros, because I can fudge a graph. It doesn't have to be drawn to scale to make it work. Calculator is going to want to make it scale. So that means you'd have to adjust your windows to know, okay, I had a 0 at -60, I had a 0 at 100, so I have to go to my window, make it -65, my maximum at 105. I graph that, and I'm going to see it crosses the axis. Yes, ma'am?
Couldn't you just make it fit and then do
You can do that too. But then it's just, that's going to give you your maximum sales figure, but you still, sometimes the questions are asking what would your multiplier have to be. But it's still, oh, I'm sorry. I didn't even look at it was you. I'm sorry. Otherwise I would have held the door. I'm really not a jerk. She's rolling her eyes probably at me. It's true. It's true. So it still works the same way, guys. It's just a matter of adjusting windows. And plus, if you go to your table, you'll see that you've got certain values. If I have my multiplier at there's something up in here. Yeah, this is what, it's just a very simple, we try to use whenever you're doing cost sales ones, I cannot stress the importance. Try to use intercepts. Try to use that intercept form for finding zeros. It is a much cleaner method to find things, okay? Question on that one. Jolie asked me earlier where she could find more of these things, because I know that we've done a ton of them. I told her just to quite literally Google cost sales quadratic PDF. You will find a ton of them, okay? It's a very, very simple thing to do. What I want to do, though, is, I know we only have about 10 minutes here, the other style that I'm going to work with the other class tomorrow is going to be, again, to look at the, what was one word sheet that had the, oh yeah, the art border. Okay. So you guys should still have this worksheet that had all the word problems on. I asked that second hour, just kind of revisit that tonight, just to kind of go back and look at them. And yeah, what Haley has right there, what is it, like 6 pages or something like that? Go back over some of those tonight, and we're going to continue working on those. Plus, I have a few more that I'm going to write out tonight to give to you guys tomorrow to look at. Excuse me. And go from there. So this is the style where you have a building, a mural, or you had grass, you're putting a patio around something. We're doing that border of equal width. Okay? So this one had the mural where the building itself was 50 by 30. And the artist wanted to devote 25% of the available space to the border. What should the width of the border be? So the sides of the building are 30 by 50, which is going to give you a total square footage of 1,500. Everybody okay with that? Okay. Now we want this border of uniform width to go around to be equal to 25% of the whole thing. Yes, ma'am?
Couldn't you also just take like 25% of 30 for the one side and like then divide that by 2 and then you've got the 2 side lengths for that side, then like you could take 50, 25% of that.
When we multiply percentages through, it doesn't work out. Yeah, because it'd be great if it would, but if you take 25% of one number times 25% of another number, it is a combination of 25% of the area. Yeah, I always thought that would work too. It seems like it would, because you wind up multiplying out value. So what we're trying to do here is we know that our total area was 1,500 for the whole thing. We want our border to wind up equaling, excuse me, what would that border be? It was 25%. So we had to figure out what's 25% of 1,500. Well, what's half of 1,500? What's half of that? 375. So we want the border to equal 375 square feet. Okay? So the border should equal that, but we need to figure out what is that border going to be. Well, if the whole wall is 50 by 30 and we have uniform width going around, we need to figure out these new internal dimensions. Yeah. Okay. Now, excuse me, what should that internal area equal? The outer border is 25% of 1,500, 375, which leaves you an internal area of just the two parts subtracted out. And what was it, 1125?
Yeah.
So this new internal area has to equal 1125. Okay? And now you set it up in terms of a quadratic. And go from there. In this case, we were subtracting out. Other problems, if you had to add a border in, you would add uniform width. Okay? Sometimes they'll give you the overall, the new, what do you call it, border area. Sometimes they don't. But that's how these things work themselves through. Okay? Been broke for a few days.
Oh, really?
But it's right twice a day.
Hey, I haven't been here for like.
We've missed you.
What?
You okay?
Yeah.
You're not gonna fall over like a turtle, are you? Good luck. Would you like me to get the door for you?
Sure.
La Puerta? Sure. Okay. Finish looking at some of these for tonight from that old sheet. I will have a printout of some newer ones for tomorrow, and we'll continue working. I know we're only going to have about 25 minutes tomorrow, but we're going to knock through a bunch of them. Yes, ma'am. What's that? FOIL set it equal to 0. Find zeros. Yes, ma'am.
So you just want us to review some of the work we did?
Yeah, and then we'll go over more that's wrong. And I'm going to have a couple more of these to give you guys some. We'll do a quick little handout, try and knock out 2 or 3.
If we equal it to 0, what is it? 1125.
Send it over. Foil this out, send over the 1125.
Foil out of this 4x squared minus 60x plus 1500 minus 1125.
Equals 0. And then what are you looking for? You're looking to find your zeros. One of them will probably be positive, the other one will probably be negative. Do you want negative border? No. Or if you, well, I think one of these problems had a border where the border was wound up being bigger than the actual dimensions. So you just have to look at what you're given for your x values. Go from there.
Wait, so if I get all the word problems right,